Hi, so we've got a Samsung Note 9 with us today for data recovery. This phone was water damaged and then it was taken to another repair shop where they tried to fix this device. It's got a pretty, uh, it's got a story. This phone came in with a letter from the other technician. So, anyhow, our goal is to get this water damaged Note 9 recovered slash repaired enough to recover its data. So with the board under the microscope, if I try to power it on with the DC power supply, it draws about 600 milliamps when I press the power button. And then once I let go of the power button, it continues to draw power for about a second and then turns off. Um, and then that is where we are now. So let us proceed. What I'm going to do is we'll check it with a thermal camera, and we'll see if the device shows us a heat signature. So I have my thermal camera ready here. Let us pop it open, and we'll see if we can detect any hotspots. So I have the phone plugged into my DC power supply. All right, with the phone plugged into the thermal camera, let us prompt this phone to boot and see what it does. Okay, as soon as I press the power button, I do see a hotspot in the top left corner of the board. Let's see if there are any other hotspots that we can find. Now, so far with the shields still on the board, there's a hotspot in the top left corner. Let us take the board out of the housing, and then we'll check it on the other side, and we'll see if we're able to spot that hotspot. So this time I'm going to prompt it to boot with a couple of tweezers, and then we'll look at that area once again. Okay, so there's a shield next to the rear camera, and it's got a pretty significant hotspot underneath it. Let's pop that shield off, and we'll take a look. So that shield definitely looks crooked. It's quite possible that that short circuit is because of that crooked shield. Let us pop it off, and let's take a look. I'm going to use 370 Celsius at 50 airflow. It looks like the shield was low melted back on there. Possibly. If it was low melted, it should come off very easily. Solder is melting quickly. Could be leaded solder, which is still okay. Still gonna come off fairly quickly. All right. Well, no wonder it was shorting out. So the underside of this chip is quite exposed, and then we've got a couple of components here that were not on properly. Let us fix them up quickly. We'll fix this capacitor. Oh wow, there was a spot on there already. So I don't know if that cap goes there or there. Well, that is interesting. Let's clean that area up first, and then we'll see, because whoever soldered on there never cleaned it. And I can't really tell what's going on. So let's zoom in. So that QFN was budged when this person attempted to solder on this board. And I think that's why it is short-circuiting. Let's fix it quickly. And then we'll see if we can prompt this device to boot. That's actually a BGA, not a QFN. It's also chewed up quite badly. What the hell was this person doing? Okay. Now that we've fixed up that area a little bit, let's power it on and we'll see if it works now. We'll cool it down first. Once the board cools down, we'll attempt to power it on and we'll check. All right, so with the motherboard fully cooled down, let's prompt this Samsung phone to boot, and we'll see if it's any better. No, it still draws about 600 milliamps and turns off. Let us check it with the thermal camera, and we'll see if any of those chips are showing a fault. Okay, let's prompt it to boot. The power button is disconnected. And the battery connector was disconnected. All right. Okay, it looks like that QFN is heating up. Unless something under the shield is heating up, it's possible. Let's take a closer look. Okay, so there are two components on here. So we've got this we've got this QFN IC that is showing a heat signature on prompt to boot, but then we also have a heat signature. That heat signature could also be because of a component under this shield. And there was a resistor or a cap or something just hanging out. We're gonna set that guy aside. I have no idea where it came from, but we'll set it aside. So let's take that shield off and we'll see if anything stands out. So we're gonna do the same thing 370 Celsius hot air at 50 airflow. And look at that. I think I know what our problem was. That cap was shorting out to that ground plane. Let's clear that short and we'll check and see if it works. And also we'll clean up that area. Excellent, that looks so much better. All right, let us prompt this device to boot once again, and hopefully it's fixed it this time. All right, so we've taken off the shield and cleared a capacitor that had short-circuited to the ground plane, or to the shield. Let's prompt this Samsung Note 9 to boot. And still the same. All right, let's put it in the housing, prompt it to boot, and we'll check that other side. All right. Okay, so it's that IC chip that is showing a short circuit. Let's take a look at the schematic. We'll see what that chip does. And then let's see if we can find out if that chip is short circuit or if, if that chip has a short circuited capacitor or if it is internally short circuit. So I'm going to start by first checking to see if there are any shorted caps around that chip. Okay. That's good. All right, so that coil is showing a short circuit. So we've got a short circuit on this line. Let's check the schematic to see where it goes. Okay, so in the schematic, this is labeled as U9001, and it looks like that coil connects to the chip internally. It doesn't go anywhere else, and that line is labeled SWB2 and SWA2. And apparently this is a sub-PMIC. And it looks like it puts out voltages for the cameras and the proximity flex. I don't know if this is necessary for boot or not, but let's take this chip off and we'll see if if the short circuit still remains. Now we're taking this chip off because there's still, there is a distinct heat signature under the chip, and one of the coils that's attached to the chip uh, goes nowhere else but the chip, and it shows a full short circuit. It's on the camera circuit from what I can gather. Okay, the chip is off. Let us see if it still has the short. All right, so with the chip taken off, that short is removed. Excellent. We'll let the board cool down, and then we'll check and see if it works and boots on. Because if that chip is not necessary for the phone to boot, we may be able to recover its data. If it's necessary for the phone to boot, then we will have to replace that chip before data can be recovered. All right, it's cooled down. Let's plug it into power, and then we'll prompt it to boot. All right, so we've just removed the bad chip. And after removing the chip, the short's cleared. So let's prompt it to boot. and it does not boot. It draws 50 milliamps and then back to 0. Okay, so we will need to replace that chip in order to fix this device. Let's see if I can find a donor. All right, luckily we have a donor motherboard, and then, whoa, I almost dropped it. Yeeks. This is the customer board with the missing chip, or with the bad chip, and then this is the donor we're going to harvest the chip from. So let us put it under our microscope. We'll take the chip off and then we'll reball it. So I have my hot air set to 400 Celsius at 50 airflow. It doesn't look like the shield has ever been touched, so it will have all the lead-free solder holding it to the board. So it may not. And it came off. Excellent. All right, let us remove the chip. Excellent. Our chip is off. We'll clean up this board in this area. All right. We'll fix that capacitor quickly. I don't need to, but since this is a good donor, I would much rather fix it now and possibly have other problems. Excellent. Fix the cap. Let's clean it, and then we'll reball and prepare the chip. All right, the board is clean. Let us set it aside. Now let us reball and prepare the IC. First, we're gonna tin all the pads with some fresh solder, and then we'll clean the chip, and then we'll reball it. All right, this iPhone 7 PMIC stencil fits it quite nicely. So we're just going to use that and reball it. So I'm going to do 300 Celsius at 60 airflow to reball it. Excellent. Chip is reballed. All right, let's pick up all the excess solder from the stencil and our table. Wonderful. Let's reflow the IC and then we'll clean the chip and the stencil and then put the chip on the board. All right. Beautiful. Let us make sure the reball is perfect. Fantastic. All the balls are the perfect height. It is ready to go. Excellent. We'll set this aside and we'll clean our stencil. All right, so now we're going to tin and braid the pads on the board, and then we'll put the replacement chip on, and hopefully that'll fix it. Also, I kind of forgot the orientation of the chip, so we're going to have to double check on that too. Hooray! Should have made note on the board. Okay, we're going to tin these pads on the board first, and then we'll braid it, and then we'll put the chip on. All right, have some fresh braid. Let us tin these pads. When they're all surrounded by components, it's always a little bit difficult. So the trick I like to use is after you've tinned it with low melt solder, just touching the braid with the iron is usually enough to transfer enough heat that it will melt the solder on the pads and get wicked up onto the braid. You should never have to apply too much force. If you have to apply force to braid the pads, you will pull pads or damage the PCB or scrape the PCB mask. You have to be gentle when doing this job. Okay, pads are cleaned. Looks like we've got one solder pad that is stubborn. Let's see if we can get rid of him. Maybe with just the iron. That's good. That did it. Excellent. Let's just braid it because one of those guys is showing a tail, and yeah, there's not enough room in between them. I don't want problems after. I think that is good. A couple of pads in the center are proving stubborn. There we go. That did it. It didn't look like it, but the braid got saturated with too much solder, and then I had to cut the excess off, and that did the trick. Excellent. Now let's clean and then put the chip on. Beautiful. It is cleaned now. Let's grab our chip. Well, first we'll put some flux on the board. And then let me quickly verify the orientation. All right. The dot is in the same orientation as the arrow, which is excellent. Okay, let us put the replacement chip on. The orientation we are in, the dot is going to be in our bottom left-hand corner. All right, I'm going to use 370 Celsius at 50 airflow to put the chip back on. Now, when the solder holding the chip melts, it should snap into position on its own if my positioning isn't perfect. And it moved. Perfect. The chip is back on. Awesome. Let us check and see if the short is now gone. And look at that, the short is cleared. Excellent. I think this phone is going to boot now. We'll cool it down quickly, and then we'll prompt it to boot and check. Okay, the board is cool. Let us plug it in. And glasses. Okay, so now with that chip replaced, let us prompt this phone to boot, and we'll see if it works. All right, that's much better. All right, based on the DC power supply current draw, looks like the phone is booting. This is excellent. Excellent. Okay, let us pop it in its housing and we'll see if we have image. All right, this is the moment of truth. Oh, power button. Awesome. We have image. It is booting. Excellent. It's past the first level of boot. Awesome. The device boots fully. Data is saved. Excellent. Excellent. Let me put the code in and we'll make sure. Um, awesome. Device is unlocked and it has been saved. Excellent. The data recovery was a success.